All right, so we're going to talk now about dilution. Dilution, very, very important concept in chemistry and life, because we all know that there's only one thing that can really spoil a party. What's that? What do you think, Fred?
What? What are we talking about?
Something that can make a party bad, or how do you know when you go to a party that it's going to be a bad party?
I don't know. Your friends aren't there?
Yeah, that's kind of important, but there's something else.
I don't know what you're talking about.
Well, it's the punch, right?
The punch? What do you mean?
Like, you go and get a drink and punch.
Oh, the punch? That's how you tell if it's a good party or not?
Yeah, usually, right? Because if the punch tastes good, then you know that somebody has put in the effort. But if the punch isn't good, they just didn't care very much, and it's not gonna be a very good party. Have you ever gone to a party and the punch is really sweet?
I guess.
Well, what do you do?
It's not that big a deal. You just add water.
Yeah, you can add water. And what do you call that?
That's diluting.
That's right. That's dilution. And I'd like to draw upon your experience of knowing that you can add water to a punch to dilute it, to help us recognize numerically how we can use an equation to know what kind of dilution we need to do to get a specific concentration that we're after. Okay, so for example, let's say you're at a party and you have your punch, okay? And your punch, here it is. It is too concentrated. I'm going to draw it here as a dark solution. It's just too concentrated. All right? What do you do to dilute it? You said add water, right?
Yeah, just add water.
That's right. Now, but what if I wanted to dilute it a specific amount? Like I want it half as concentrated. What would you do then?
If you want it half as concentrated, you just have to add the same amount of water as your punch, right?
That's right. That's right. So that is something that we have enough familiarity with. So if I take my same volume of water here, all right, so this is just water now, and I combine it together, I'm going to have a little bit larger volume, but my new punch, right, is going to be half as concentrated. Half as concentrated. So let's give this concentration, let's say it's a 10 molar, okay? 10 molar. And let's say this concentration over here is 5 molar. All right. Well, there's a relationship between the concentration here and the concentration here and the volume that you started with. We'll call that the initial volume and the final volume. Right? Okay. This here we'll call the initial concentration, and this we'll call the final concentration. And you see the equation on the slide there, but there will come a time, maybe in the not so distant future, where you forget that equation. And that's completely understandable. If you're really good at memorizing stuff, you'll remember it for the tests, but we're more interested in you being able to recreate this equation, regurgitate it yourself from your memory, okay? So let's give this a volume. Let's say this was 2 cups. And what would the final volume here be?
I don't know. How would we know the final volume?
Well, didn't you say we have to add the same?
Oh, yeah, so it's going to be 4 cups.
That's right, because we had to add the same amount of water, right? So we have our initial concentration over here, 10, our final concentration, 5 molar, and there is a relationship between the two. The initial concentration here was our 10 molar, right? There's a relationship that exists. And you can just try and find out what that relationship is, and you'll find it really quickly. And what it is it's C1V1 equal to C2V2 or CFVF. So sometimes say C1V1, C2V2, or CIVI, meaning initial volume, initial concentration, or initial volume, initial concentration, final volume, final concentration. Okay, so let's see if we can use this equation now to answer questions for ourselves. First, let's look at how this is done a little bit in the lab, right? We have volumetric material, or tools, volumetric tools, that we can use to transfer precise amounts of more concentrated material, and then we can dilute it with water up to the appropriate volume and get a more diluted solution. All right, so what volume of 12.11 molar HCl is needed to create 250 milliliters of the 3.2 molar? Now, if you think you got it, go ahead and push pause and try to solve it. Otherwise, we'll solve it together. Okay, so hopefully you had a chance to try it. What do you think, Fred?
What was the equation again?
Well, I'll give it to you this time, but remember, you're going to be trying to regurgitate that yourself in the future, right? So, which values do we have here in this problem provided for us?
C1 is concentration initial, right?
That's right.
So that's 12.1 molar.
Very good. So 12.1 molar.
The initial volume is what they're asking about, so we don't have that.
Very good. So I'll put an X there.
The final concentration we want is 3.2.
3.2 molar. And the final volume?
It says it's going to, we want to create 250 milliliters, so 250 milliliters.
Okay.
Does that have to be in liters?
Actually, no. It doesn't matter. Whatever units we have over here, however, are going to be what we find out here. And the units that we choose for the left side concentration have to be the same as the right side, right?
Okay. So they just have to be the same on both sides.
That's right. So 3.2 times our 250 divided by our 12.1, that should give us our volume, 66 milliliters. And what volume is that again?
V1.
Yeah, but what is that volume? What does V1 represent?
It's the volume of the 12.1 stuff.
That's right. It's the volume of our concentrated HCl that we're starting with, that we're diluting down. Very good. How about this one? Try this one at home. I'll leave that equation up there for you so you can try it. All right. Hopefully everybody had a chance. What's our initial concentration?
6 molar.
That's right. We're starting with 6 molar. And we want to find out what the molarity will be after we do this dilution, right? So we don't know the final molarity. Okay, so what's our initial volume?
25 mils.
Very good. And if we're diluting it to 500 mils, how do we dilute it to 500 mils? Does that mean we added 500 mils of water?
Yeah, you had 500 mils of water.
Well, think about that well. If we added 500 mils of water, what would the final volume be?
Oh, it would be the 500 with the 25?
That's right. So we're not actually adding 500 mils of water, are we?
Oh, you're only adding 500 minus 475?
That's right. You're only adding 475 of water. But 500 is the final dilution after you've diluted it with water. So that will be our final volume of 500. But it's important to recognize that it's not adding 500 mils of water, because some questions will say, then you add this much water, what's the final concentration? But it's not how much water you've added, it's the final volume that relates to the initial volume and initial concentration. All right, good. So we got this one done. So the answer is 0.3 molar. 6 times 10^25 divided by 500 will give us our resulting concentration, and the units will be the same as they are over here. All right, good job. Okay, here's a good one for you to practice. Why don't you try it? Okay, hopefully everybody at home had a chance to try it as well. What is it, Fred?
I think the answer is B.
B? So how did you get that?
Well, I took 3.11 is our initial concentration,
Very good. 3.11
and 20 is our initial volume.
milliliters. I'll put a little M in there for molarity. Good.
And then 15 milliliters as your final volume.
Okay, so what did you do for your final concentration?
Oh, that's the unknown.
Okay, so you said 15 milliliters here for the final volume?
Yeah, 15 milliliters.
Okay. And that's how you got 4.15?
Yeah.
All right, let's check it out.
That's not right. 1.77 is wrong. If you do the math, it's 4.15.
Okay, but are we sure that we've set it up right?
I think so.
Okay, does anything look fishy about 4.15 as an answer?
I don't think so.
Well, didn't we add water and now we get a higher concentration? We started with 3.11 and we go up to 4.15.
Oh, yeah, that is fishy. Oh, I think I know what the problem is. We added 15 mils of water. That wasn't the final volume. So the final volume needs to be 20 plus the 15, which is 35.
Very good. So this needs to be our 35, and then that will get us our 1.77, right?
Let me try it in my calculator. Yeah, you get 1.77.
Okay, excellent job. Very good. Good work today.